Yes, sir.
अच्छा, अब ये था कि ये मैं फिर से रिकैप कर लूं कि वी वर डूइंग कि विच एसिड्स वर स्ट्रांग, विच एसिड्स वर वीक। ठीक है। तो उसके अंदर था कि अल्कोहल्स वर लाइक टेरेबल एसिड्स। अल्कोहल्स, उनका सिर्फ एक रिएक्शन था, विच वाज दैट इट वाज दे जस्ट रिएक्टेड विद सोडियम मेटल। Phenols जो थे, they were slightly stronger acids. They would react with the reactive metals with strong bases. लेकिन they would not react with weak bases. ठीक है, इनके साथ वो react नहीं कर रहे थे। और carboxylic acids वो सारों के साथ कर रहे थे। They were reacting with weak bases like carbonates and ammonia, with NaOH, with sodium metal as well। ठीक है। तो हमने, मेरे ख्याल से लास्ट टाइम हमने एक्सप्लेनेशन पढ़ी थी कि alcohols का किया था कि why are alcohols extremely weak acids? Because they dissociate. But when they dissociate and the ion is produced, तो वो जो your alkyl chain has an electron donating effect. So the negative charge density increases over here. And if that increases, the H plus one is strongly attracted back and it will not dissociate. ठीक है? The bond between the O and H will be a lot stronger. ठीक है? So which is why alcohols, they don't like to, the reverse reaction is going to be favored. The alcohols don't like to dissociate. ठीक है? और फिर था you had phenols. They both, and alcohols both have OH groups, but phenols are stronger acids. Why are phenols stronger acids? So it's going to be discussed that in phenols the same thing happens. The OH dissociates. Like what happens is that the electrons on the oxygen, they overlap with benzene, and when they do that, the negative charge density is smaller, which is why it's not going to attract the H plus one. So the O and H, they don't really attract a lot, which is why it's easier for it to dissociate. ठीक है? Clear है ये? Zuhair, Irfan, Mahini, is this clear?
Yes, sir.
अच्छा, उस पे आना था लास्ट वन, कार्बोक्सिलिक एसिड्स। दे वर द स्ट्रॉन्गेस्ट एसिड्स। ठीक है। सो कार्बोक्सिलिक एसिड्स आर रिलेटिवली, अच्छा, दे आर रिलेटिवली द स्ट्रॉन्गेस्ट एसिड्स। तो व्हाई डू दे डिसोसिएट सो मच? अच्छा, सो you've got carboxylic acids. Why do they dissociate so much? So for example, if I have a carboxylic acid, it will dissociate. The O and H will break down, and you will have the ethanoate ion in this case. And the H plus one will break down. I mean, the H plus one will dissociate. Now, what happens in the case of carboxylic acid? Now, in the case of carboxylic acid, there's an oxygen next door, and that oxygen has a very strong electron withdrawing effect. So, since it has a very strong electron withdrawing effect, the negative charge is like really small. So, the negative charge density decreases a lot. ठीक है, clear? There's a very strong electron withdrawing effect. ठीक है.
Yes, sir.
So, because of this, there's going to be very less attraction. The attraction between H plus one and O minus one, that attraction would be a lot lesser. Hence, the dissociation is going to be a lot. The O and H are not going to attract. The O and H are not going to attract each other very much. So the explanation for this is that the oxygen, the oxygen in serial bond O, has a strong electron withdrawing effect. So it's got a strong electron withdrawing effect. And so the charge density on the ion decreases. So charge density on the ethanoate ion, CO minus 1 ion, it decreases a lot. And once it decreases, so there's going to be less attraction for H plus 1 ions. And you're going to have more dissociation. Okay, so you can say less attraction for H plus 1 ions or the OH bond, the bond between the O and H weakens. Okay, so therefore you're going to have more dissociation. Therefore you have more dissociation and you have relatively a stronger acid. ठीक है ये clear है?
Yes, sir.
ठीक है, so just remember that in alcohols, the alkyl chain has an electron donating effect. So negative charge is too much, the attraction is a lot less, so almost no dissociation. Phenoxide, the negative charge kind of overlaps with benzene's pi electron cloud, so the negative charge becomes much smaller. So you have slightly more dissociation because the attraction decreases between the O and H. In carboxylic acids, the electron withdrawing effect is a lot. There's a very strong electron withdrawing effect, which is why the negative charge becomes really, really small. And you have a lot more dissociation in this particular case. So you've got these three things happening. The summary is that if you have a withdrawing effect, the acid becomes stronger. If you have a donating effect, the acid becomes weaker. Is that clear? Okay, that's the overall summary. So electron withdrawing effect or withdrawing group, if there's an electron withdrawing group around the OH. So that would make it a stronger acid. जैसे ही ऊपर है, like in the above one, you got CO group right next to the OH. So that makes you got a stronger acid in this case. Or vice versa, if you have an electron donating group around the OH, then you're going to have a weaker acid. Okay, that's the overall summary of what's happening. So is this part clear? You
Yes,
clear?
sir.
Yes.
Okay, so that's basically now the thing is we're gonna do comparison within carboxylic acids and within phenols as well. So comparison within carboxylic acids or comparison between carboxylic acids. So for example, the first one, number one, if you have longer alkyl chains, if you have longer alkyl chains, there's more electron donating effect. I'm going to write the reasoning as well. If you have longer alkyl chains, there's more electron donating effect because alkyl chains have electron donating effect. Uh, and you'll have a weaker acid. So the OH bond strength increases. There's going to be more electron density on the OH, so the bond strength increases. And that would lead to less dissociation or weaker acid. So for example, I've got propanoic acid. So this is propanoic acid dissociating. And I've got ethanoic acid or ethanoic acid. So so propanoic acid does not like to dissociate. Why? Because there's going to be an electron donating effect, and it's going to be more electron donating effect. So the negative charge is going to be a lot larger. In the case of ethanoic acid, the electron donating effect is not going to be that much. So the negative charge density is not going to be that high. It's going to be smaller. So in the first one, you'll have less dissociation because the O and H are going to attract each other very strongly. And in this case, they're not going to attract each other that strongly, so you'll have more dissociation. ठीक है? Is this part clear?
Yes,
Yes,
sir.
sir.
I said now, so that's one thing, ठीक है? Comparison between acids. Then there's going to be a comparison of chlorine substituted compounds. Second. So there's going to be another comparison, and that comparison would be um, chlorine substituted carboxylic acids. Now, when you have chlorine substituted carboxylic acids, remember, chlorine has an electron withdrawing effect. I said it's got electron withdrawing effect. So if I have, let's say I have a molecule with three Cls that are attached to it, and it's got a carboxylic acid. And let's say that carboxylic acid is dissociating. And I've got another molecule, and that molecule has only one Cl. And so I've got these two, three things. So in the first one, there's more electron withdrawing effect because I've got more Cls, right? Is that clear? The Cls are withdrawing electrons. In the second one,
Yes, sir.
there's slightly less electron withdrawing effect. Okay? So the negative charge in the first one is going to be a lot smaller, small होगा. While in the second one, the negative charge is going to be a lot larger. ठीक है? Is this clear? Okay, in the first one, there's a lot more electron withdrawing effect. ये clear? Is that part clear?
Yes, sir.
Yes.
So in this one, there's going to be more dissociation because the O and H are not going to be attracted to each other. So there's going to be more dissociation. And this one would be less dissociation. So basically, the summary is that you've got bigger alkyl chains. I mean, the first one was bigger alkyl chains, weaker acid. That's the summary for the first one. Okay, that's the summary for the first one. For the second one, the summary is more Cl atoms, and that would mean stronger acids. Okay, is this so stronger acid? And then there's a third one as well, which is the position of the Cl. So if the position of the Cl, so position of Cl, this is what I mean by that. So I've got, let's say I have the same number of exact Cl atoms. Let's say there is butanoic acid, and that butanoic acid is dissociating, and it's producing H positive ions. And these are all, so there is a CH2, a CH2, another CH2, and then there is a Cl that's attached right at the end. And then there's another butanoic acid. TK, you got -1, and this is plus, and it's dissociating, producing an H plus 1. Now over here, it's again, this is CH3, CH2, and CH, and there's a Cl over here. And so now in the first one, the Cl is like really far away from the OH group. Second one, the Cl is like really close by. So in the first one, the electron withdrawing effect is the same. But whose electron withdrawing effect would more affect the negative charge over here? This case or this case?
The second one?
The second one, ठीक है? So उसका rule ये है कि if Cl is closer to the OH group, then it's going to create a more so there's going to be stronger electron withdrawing effect, and that would lead to stronger acids. So, and you will have stronger acid. ठीक है? तो and remember, these are not the only groups. They could bring in any group. ठीक है? You just have to decide based on this idea that if you have electron withdrawing effect, so the acid is going to be stronger. And if you have electron withdrawing effect, then the acid is going to be weaker. Okay, so there are three. I mean, mainly it's these three. Okay, but is this part clear? You clear?
Yes, sir.
So I'm going to come to phenols as well because phenols had those electron donating and withdrawing groups as well. Okay, basically you're going to do the same thing. Okay, I mean we've studied like a long time back. We studied. Okay, we studied electron withdrawing group and donating groups of benzene, right? So you're going to apply the same thing. Remember amines, phenols, and alkyl groups. They're all electron donating groups. NO2, aldehydes, carboxylic acid, CN, TK. This is the NH3 group. They're all concept group and the electron withdrawing groups. So coming back to, so we can do a few cases for phenols as well. So I just want to, we'll just try and figure out whether it's going to be a strong acid or a weak acid. TK. So I have this benzene. And this benzene has an OH, which would dissociate, right? Now, if I attach an alkyl chain, an ethyl group, so would this be a stronger acid or a weaker acid? More dissociation or less dissociation? Like even if this dissociates, क्या होगा? Fan, any idea? Maheen, Zaina, Zuhair.
Yes. I think
Less.
so more.
What will happen to the negative charge? That will be larger, right? Donating group would make the negative charge large, and if it becomes larger, that would lead to stronger attraction between an O and H, right? तो उसका मतलब
So what about the elect
क्या हुआ है?
वहां पे तो वो मतलब कौन सा क्लाउड होता है पाई इलेक्ट्रॉन क्लाउड तो दोनों मिक्स नहीं होते तो फिर उसकी वजह से वो ज्यादा स्ट्रोंगर नहीं होनी चाहिए
नहीं नहीं, I'm just comparing with this phenol. वो तो like if you're comparing it with a normal phenol,
ओके सर
ठीक है?
यस सर
मतलब for example, if I compare it with, so this is within phenol comparison, ठीक है? I'm not comparing it with some other group. So let's say I have another one. In this case, this side has a nitro group, which is an electron withdrawing group. ठीक है? तो यहाँ पे there is a nitro group, and that's an electron withdrawing group. So now what's going to happen is that the negative charge on this side will actually become small. ठीक है? Because the overall effect of this NO2 would be that the electrons will be pulled slightly to the left. So there's going to be less attraction. This is going to be a lot stronger acid. So in this case, there's going to be less attraction. Is that clear?
यस सर
Yes, sir.
So basically, you just have to figure this out. Okay? You just have to figure this out that, um, ठीक है, that's the summary. इस ज़्यादा हो गया एक second. So that's your overall summary, which is, I mean, you have to keep this in mind. Withdrawing group, that makes the acid stronger. Donating group, that makes the acid weaker. ठीक है, clear है ये?
Yes, sir.
So that's all about acids. ठीक है, we'll do past paper questions, but we'll do that after we study bases. I said bases. What were your bases? So your bases were nitrogen compounds. Most nitrogen compounds are basic. Why are they basic? What's a base, by the way? A base is something that accepts H plus one ions, right? That's what a base is. Now, why do nitrogen compounds accept bases? Because or they act as bases. Why do they accept H plus one ions? Because, for example, if I have NH3, so that NH3 has a lone pair, and if it has a lone pair, there's an H plus one around. It can datively bond to that. It can datively bond to that lone pair, and it can form. I mean, it's going to form ammonium ions. ठीक है, तो ये clear है that why do nitrogen compounds accept H plus one ions?
Yes, sir.
तो यहाँ पे ना there's going to be a dative bond, and the whole thing will have a plus one charge. ठीक है. So the lone pair accepts anything that has a lone pair is potentially a base. So you've got many nitrogen compounds. So the first one is amides. Amides are what? They are C double bond O and NH. Okay, that's what an amide is. So then you have ammonia. Ammonia is used as a reference. This N has lone pairs. This N over here has lone pairs. Then you have the phenylamine, the benzenamine. So that one has NH2 and it's got lone pairs. Okay, the ammonia is actually, let me correct the order, bring this over here. Finally, there's another amine which is alkylamine. And alkylamines are the ones with alkyl chains. And then there is NH2, right? So let me name them as well. This is amide. This is phenylamine. That's ammonia, and that's your alkyl amine. Okay, so four compounds. Now the strength as bases, the left one is the weakest base, and the right one is the strongest base. Okay, let me correct this. So this one is the strongest base, and remember, relatively, they're all actually weak. Okay, so the right one is the strongest base, and the left one is the weakest base. And you've got a spectrum. Okay, is this clear? Okay, which one is stronger, which one is weaker?
Yes, sir.
This is a one by one. We need to explain. Okay, what's wrong with amides? The first one. The first one, amides. Amides are actually not basic at all. Okay, so when you have an amide, they're actually not basic. They don't actually accept H plus ions. So why is that? Why are amides not basic?
Because, sir, they have
क्या हो रहा है?
सर उनके पास इलेक्ट्रॉन विथड्रॉइंग ग्रुप होते हैं इसलिए
हाँ ठीक है, because they've got a lone pair, but they've got a very strong electron withdrawing group. So the lone pair actually ends up overlapping with the double bond over here. So the reasoning is that the oxygen in C double bond O has a strong electron withdrawing effect. So what that does is that the lone pair on N overlaps with pi bond with C double bond O pi bond. And since it's not there, it cannot accept or attract H plus 1 due to low charge density. Because the lone pair is busy somewhere, okay? It's not present. This lone pair mixes with the double bond over here, and it's not there, so it won't accept H plus ions. ठीक है, is this clear कि why amides are not basic?
Yes, sir.
ठीक है, so amides are not basic. Moving to the next one, phenylamine. They're actually relatively weaker bases. Why are phenylamines a weaker basis? Because इसके अंदर भी there's an electron withdrawing effect. So number two is that are relatively weak. They're relatively weak bases. The lone pair mixes with, so the lone pair is there, but the electron withdrawing effect is not that much. So overlaps, the lone pair on N overlaps with benzene's pi electron cloud, ठीक है? Which decreases its charge density. So hence, lesser attraction for H+ ions. ठीक है, clear है phenylamides. Is this clear?
Yes, sir.
Fa-
Yes, sir.
और number three, alkylamines. They're like उसकी रीजनिंग क्या होगी? That number three. So alkylamines actually have. So number three is alkylamines actually have an electron donating group. So this group over here has an electron. Alkyl groups have an electron donating group. So यहाँ पे what's going on is that the alkyl chain has an electron donating effect, which increases charge density on lone pairs on N. Hence, there will be stronger attraction for H+ ions. ठीक है, is this clear? All three. Why is one stronger than the other one? The lone pair over here is going to be it's going to be having a much stronger charge density, right? Clear है ये?
Yes, sir.
तो बस ये basis का हो गया, ठीक है? Basis is exactly the same, except and then also remember that in bases it's the opposite. That if you have an electron donating effect, you actually become a stronger base. तो वो summary लिख लो कि the summary for bases is if you have more electron donating effect, so that would mean you are a stronger base. ठीक है, that's the summary for this. ठीक है, is this clear?
Yes, sir.
तो चलो ठीक है, we'll do past papers next class में, ठीक है?
ठीक है सर, ओके सर, अल्लाह हाफिज।
Thank you, sir.
चले,
Yeah,
ओके
sir.
Thanks, sir.
ओके, टेक केयर, बाय।
Assalamu alaikum, sir.
वालेकुम
Hello?
सलाम। जी जी।
Sir, I just wanted to talk to you about the class and ask you some questions.
Yes.
So sir, right now are you on chapter 26 of the
Yeah, in
syllabus?
this one we're doing organic, and
Yes.
we're actually in the middle of organic, by the way. We'll do
Right.
I mean, this is how we're going. Let me explain just a second. Yeah, where's this summary? Just a second.
Okay.
Yeah, so what we're doing is, I mean, right now we're kind of somewhere over here, right?
Right.
So we'll
Okay.
we'll do analytical techniques after that,
Okay, right.
and you probably you probably might have. I mean, did you get what we were talking about, by the way, in the class?
I understood, yes, some of it, but like I think
Yeah,
I've not reached that chapter yet, so I didn't understand all of it.
yeah. I mean, yeah, we were in the middle of this subtopic as well. Like we already started with that with the acid thing, right?
Yes.
So we're gonna do analytical techniques, and then we're gonna start all over again.
With physical chemistry.
Yeah.
Okay. So you've done physical chemistry before, or this is going to be the first time with the class?
No, this session was. I mean, this is like this one is going on for like since September, I guess.
Right.
Like August 10.
So,
We started somewhere around August 10, right?
okay.
So so we're done with most of them, most of the topics. So
Most of the topics starting again.
but we're then going to do this. I mean, this one you'll probably get, like if you join this one, you'll get
Yes.
this completely because this has nothing to do with the rest of the topics.
Right.
Uh,
Okay.
you'll probably get
This
these.
analytical,
Hmm?
yeah, sorry. The analytical techniques, is it mainly for paper 5 or also paper 4?
Paper four, but mainly for paper four actually.
Oh, okay.
Paper five has paper five has really nothing to do with any of this. Like paper five is like very generic. It's like it's got. I mean, paper five is
Mm.
like really really easy. I mean, you've done paper five, right? I mean, have you practiced paper five?
No, I haven't started paper 5 practice. We're just starting in school.
Okay, paper
So,
five is like it's like more common sense. It's like a common sense paper.
right. Okay.
Like you just need some knowledge of chemistry. You need some knowledge of lab apparatus. The rest is kind
Mm-hmm.
of common sense. Like it's 80% common sense. That's it. So paper five, I wouldn't be worried about paper five. Uh, so paper five directly has nothing to do with all of this. Indirectly
Yeah.
it does, but directly,
Yeah.
really, they're
Yes.
not really going to ask any of this. Um,
You, how do your students prepare for paper 5 by practicing the past papers, or
yeah,
is there any other way?
mainly it's practicing the past papers.
Right. Okay.
So so paper. I mean, you need some idea of. I mean, there would be some knowledge of this being applied, but mainly it's
Mm.
just you just need to practice it. Most of the time, the answer is like right written in inside. I mean, do you remember do you remember IGCSE? Like you had the analytical question where they had the salt analysis test written at the end of the paper.
Right. Sir, actually, I did like I came originally from Scotland,
Okay,
so I did something similar to IGCSE, but we didn't have that
okay.
kind of question.
So in that case, you I mean, I wouldn't be worried about paper five. That's the basic idea. We'll just do
Okay.
past paper questions. TK, like we'll try and do we'll probably start doing past paper questions for paper five very soon.
Okay. Right.
And then we'll start from the top again. Have you done are you doing A levels somewhere?
So I'm actually like I'm enrolled in a school, but I gave October, November exams, so I missed a lot of the chapters.
Okay, so if for AS, right?
For A2, like I did October, November exams just now.
Okay. So you're left with chemistry only.
No, I did October, November. I did AS maths. That was it.
Okay.
So this year I have to give maths, bio, and I also have to give AS maths this year. But I prepared like I'm giving a resit for AS maths.
Okay. So ठीक है, I'll send you the video lectures as well. I mean, you got
Okay,
two. What you can also do is you can buy the video course as well. Like if you enroll for the live class, you'll get the video lectures anyways.
okay, yes.
But if you don't enroll for the live class, you can get the video lectures.
Okay, and like, sir, if you're gonna start from the beginning, from the like live class, so do you think I need to still watch the video lectures, or will it be enough to just attend the live class?
No, but one of them is sufficient. Like you either take the video lectures or you take the live class.
Okay, right. So your
Like
plan for the live class right now is to finish organic chemistry and go back then?
then do analytical techniques and then go back.
Okay, and or inorganic chemistry, have you covered that as well, or
Yeah.
right? And are you gonna study this afterwards as well?
Yes.
Right.
ठीक है.
Okay, so do
So
you think,
yeah.
yeah, you think it would be fine for me to join like right now this session and then stay with you and continue and learn physical chemistry and inorganic chemistry?
Yeah, that would
Or
work. I mean, that would work because we're gonna do like you're gonna get some of the organic parts, right? I'm gonna send the video lectures for the rest, which you can cover on your own.
right, okay. And so I wanted to ask about like past papers. How do you usually prepare for past papers in class?
Like in this class, we'll be doing live. I mean, we'll be doing topical past paper questions. I mean, like the ones that I don't
Mhm.
know if I showed you.
No, I don't think so.
We were actually like in acids and bases, we are actually doing these ones. I mean, in organic chemistry. This is in the
Right.
next class. These are the questions we did acid and bases right now, right?
Yeah.
So these are the questions that we're going to start doing. So
Mm-hmm.
we'll keep doing past paper questions topical,
Right.
right?
Okay, yeah.
So we'll practice. I mean, this is what we're going to do in the next class. So we'll
Mm.
cover all the topical past paper questions. Close to the exam, we'll be doing yearly past papers.
Right, okay. And when are you planning to finish the syllabus?
In the other one, it's probably going to be it's probably going to be 3 months. In 3 months,
Right, okay.
like if
So do
you
you take classes like is your other class in a different part of the syllabus?
no, the other class is actually it's more of an individual small group class.
Okay, like
I mean,
can I join that?
for this one, I mean, this particular class, this is the only live class that's happening. I mean, the other live class is more like a personalized live class. It's for a few students. I would have to
Mm-hmm.
ask them if somebody could join that class.
Okay. Yeah,
ठीक है.
right.
So you can continue with this one.
Mm-hmm. And so how many students are there in the other class?
There are three
Like,
students. There are three students in that class,
right, okay.
but those three are like friends, and wanted
Yeah, I
they just
understand what you
wanted
mean.
an exclusive class for that. I mean, the thing is that that's not going to work because for example, they have a test in school, then they have to study for that.
Yeah, I get what you mean. Okay.
So that would be too disruptive for you.
Yeah, yeah, I get what you mean. Okay,
ठीक है.
makes sense.
चलिए ठीक है.
Yes.
Let's just continue.
Sorry.
We'll have a class on Monday. ठीक है. Join that class same
Okay,
time.
right. And how many classes do you guys usually have in a week?
I mean, right now we're having 4 classes a week, but then
Mhm.
close to the exams, probably next we'll have more.
Okay, yeah, sounds good.
चलिए. Okay then.
Oh,
What's your name?
my name is Saida Fatma.
चल ठीक है. Okay, Fatma.
Okay,
Take care.
thank you.
Bye.
Yes.